Volcanic eruptions have always fascinated and terrified people. These natural giant fireworks emit streams of bubbling, boiling lava, traveling at speeds of up to 165 meters per second. As the lava spreads out in a breathtaking show, it can cause destruction, death, and doom. This flaming, bubbling hell turns into vast streams, a lethal mixture of volcanic ash, solid lava, mud, and water, which sweeps down the mountain slopes like an unstoppable river. How and where are volcanoes born? They begin life at a depth of between 80 to 220 kilometers below the Earth's surface, in a place known as the asthenosphere. The asthenosphere is actually a viscous mantle of the Earth, which allows for the movement of the Earth's lithospheric plates. Without the asthenosphere, the plates would not be able to move, and the renewal of the Earth's crust would not be possible. Where the plates touch each other, slide past one another, move under or over one another, this is where the Earth's crust is so broken that magma can find its way up to the surface. This is how a volcanic crater develops. Indonesia has been seen as symbolic of volcanic disasters ever since the eruption of the legendary Krakatoa volcano in 1883. This land, like Iceland, is referred to as the land of volcanoes and lies in the Sunda Strait, where there is frequent strombolian activity. Every now and then, some of them erupt, causing a local disaster. The same applies to Merapi volcano, literally meaning fire mountain in the local language, is arguably Indonesia's most dangerous volcano, with a history of deadly eruptions. The volcano is frequently active, with eruptive episodes occurring every few years, posing a threat to more than 1 million people living on the slopes of the volcano. This type of activity has occurred frequently in past years, usually lasting for a few weeks or months each time.
Sebagai berikut, yakni agar segera mengungsikan penduduk di daerah rawan bencana.
On 26 October 2010, Merapi violently erupted, spewing flows of hot rock and gas kilometers away from the summit and devastating the surrounding area. The huge explosion caused a collapse of its lava dome, and red-hot clouds of ash rolled down the slopes of the mountains, burning everything that stood in their way. They devastated tens of villages and all the fertile fields on the slopes. Further explosions continued daily for approximately 2 weeks before activity started to decrease in the middle of November.
Like in '94, it was the dome collapse and the seismicity and also the deformation. There was no signal.
At the peak of activity on November 5, pyroclastic flows traveled 16 kilometers from the summit, destroying everything in their path. During the 2010 eruptive episode, more than 300 people were killed, making this most recent eruption the greatest volcanic disaster at Merapi in 80 years. Over 300,000 people were evacuated from their homes within a 20-kilometer radius of the volcano and moved to temporary shelters in safer areas away from the fiery reaches of the volcano.
Saya ke sini karena kena abu dari Merapi itu. Lantas saya menjadi sesak napas dan pusing.
Ya dari apa dampak dari Gunung Merapi ini ada debu, terus ya ada riwayat tekanan darah tinggi juga ya.
Pengembalian psikisnya yang sekalian menjaga. Takutnya ada yang trauma, yang ngedrop. Target kita di sini anak-anak sama manula.
Thanks to the detailed geological monitoring and timely warnings by the Indonesian Center of Volcanology and the resulting rapid evacuations, it is estimated that 10 to 20,000 lives were saved.
All time that Merapi keeps two different activity. One eruption, explosion, and one storm collapse. Both are dangerous.
So what does the future hold for Merapi and the people living on its hazardous slopes? Scientists face a challenge to unravel the driving forces behind Merapi's activity. Past eruptions hold the key to future eruptive styles, so unlocking the secrets of what lies behind Merapi's activity will help volcanologists to prevent further catastrophes occurring. Sichuan, the second largest of the Chinese provinces. It is located in the upper Yangtze River Valley in the southwestern part of the country. The Sichuan province earthquake of May 2008. It occurred on a weekday in the middle of the afternoon. School and university classes were in full swing. Office workers had returned to their desks after lunch. 80 kilometers from the 7.6 million person megacity of Chengdu, a fault line began to rupture. The resulting 7.9 magnitude earthquake in western China's mountainous Sichuan province would kill well over 8,000 people.
Suddenly, the ground just shook. There was this awful noise. And at first, we thought maybe somewhere there was a landslide or something. We never imagined it was an earthquake. But it just wouldn't stop. And it got louder and louder, and the rocks were just being thrown down the mountains at us.
于是就是看看好像大家都有这种反应，于是就都出来了，因为原来有那个做过紧急的演习嘛。
About 4,800,000 people were left homeless, and the scale of damage to property was estimated to be over $80 billion. When a disaster occurs on this sort of scale, it is hard to single out any one statistic as especially grim.
Because the earthquake occurred in shallow, that means about 10 kilometers beneath the ground. So the damage is usually very strong, devastating.
In the 2008 Sichuan province earthquake, an estimated 10,000 children were trapped under rubble when school buildings collapsed. many would die there.
在我们在这里没有吃的，没有住的，我们淋来淋雨，我只希望有一点，尽快的找人来帮我们把这些鱼挖出来，能有一线的希望。因为它太小了，2个多月啊，整整才2个多月。
Unsurprisingly, there was a public outcry. A subsequent government investigation concluded that 1 in 5 primary schools may have been shoddily constructed and unsafe. For months after the quake, more than 20,000 students had to do with makeshift schools and classrooms. But reconstruction efforts went ahead with impressive speed. But no amount of reconstruction could erase the memories of those desperate hours in May 2008. But what causes earthquakes? When people talk about a seismic shift, what are they actually talking about? At the very bottom of the oceans lie the uppermost layers of the surface of our planet. The Earth's outer layer is known as the crust. The crust covers the Earth's surface a bit like a cracked eggshell. The various pieces that make up the crust are called geological or tectonic plates. The tectonic plates fit together a bit like a jigsaw puzzle with some rough edges, known more scientifically as fault lines. The tectonic plates move continuously against one another. Most of the time, they glide and slide along quite smoothly. Otherwise, there would be even more earthquakes. But every now and then, the tectonic plates catch, and the pressure gradually but steadily builds up. Finally, the pressure becomes too much, and the huge masses of rock which form the plates abruptly shift along the fault lines. This creates phenomenal waves of energy, spreading out in concentric circles, rather like waves in a pond if you throw a stone into the water.
Recently, especially the Japanese scientists, considering their past experience in earthquake prediction, they gave up to make investment on earthquake prediction, and that's why they concentrated on studies related to understand the physics of earthquakes.
Most earthquakes take place within the so-called Ring of Fire around the Pacific Ocean. At least once a year, Alaska experiences a 7.0 earthquake. California alone gets about 10,000 quakes a year, but most go unnoticed except by seismographs. Researchers at UC Berkeley are testing a prototype of an earthquake early warning system that California is pursuing years after places like Mexico and Japan already have them up and running.
It detects the very beginnings of earthquakes using seismometers very close to the epicenter and then predicts the shaking that's going to follow so that you can push out a warning to all of those in harm's way.
Indeed, while it is thought that globally there are as many as 500,000 earthquakes every year, only around 100,000 register on the Richter scale, and only about 100 of these cause any visible damage.